Title: Dancing with the Sun, the Tale of Solar Flares. Chapter 1. The Dance Begins. An Introduction to Solar Flares. Imagine, if you will, the sun, that brilliant, fiery ball of energy that lights up our world. But did you know that our sun, much like a skilled dancer, performs its own intricate ballet? This performance is known as a solar flare. In the simplest terms, a solar flare is a sudden, rapid, and intense variation in brightness that occurs when the sun's magnetic energy, built up in the solar atmosphere, is suddenly released. Picture it like this. The sun is like a giant rubber band ball, with layers and layers of magnetic lines twisted around each other. When these lines become too tangled, they snap and reconnect, releasing energy in the form of a solar flare. This is the theory of magnetic reconnection, which is the basis for understanding solar flares. Chapter 2. Fire in the Sky. Real-life examples of solar flares. Let's travel back in time to September 1st, 1859. On this day, a solar event now known as the Carrington Event took place. The sun spat out a massive cloud of charged particles, which slammed into Earth's magnetic field. This solar flare was so intense that telegraph systems across Europe and North America failed, with some reports of operators receiving electric shocks from the telegraph keys. Imagine the technology of the time disrupted by an event happening around 93 million miles away. Fast forward to modern times, a powerful solar flare on March 13, 1989, resulted in a geomagnetic storm that caused the entire power grid in Quebec, Canada, to collapse. This event left 6 million people without electricity for 9 hours. These real-life examples show the power and potential impact of solar flares on our everyday life. Chapter 3. Dancing with the Stars. The Challenges of Predicting Solar Flares. Now you might be thinking, if these solar flares are so powerful, why can't we predict them and protect ourselves? Well, predicting solar flares is a bit like trying to predict earthquakes. We know they will happen, but we don't know exactly when or how powerful they will be. The sun's magnetic field is incredibly complex, and the processes leading to a solar flare are still not entirely understood. Scientists use instruments like solar telescopes and satellites to study the sun and look for signs of an impending flare, such as increased solar activity or sunspots. However, these methods are not always accurate. Chapter 4. Embracing the Dance. Practical Guidance for Solar Flare Challenges. So, what can we do to face the challenges posed by solar flares? While we can't stop a solar flare from happening, we can prepare for their effects. This includes building resilience into our power grids and communication systems to handle possible disruptions. Satellite operators can put their satellites into safe mode during a solar storm to avoid damage. For us individuals, staying informed about solar weather through news or specialized apps can provide alerts about potential solar storms. In the grand dance of the cosmos, solar flares are a reminder of the sun's power and dynamism. As we continue to learn and adapt, we can better appreciate and respond to these spectacular solar performances. And just like any dance, the more we understand its steps and movements, the more we can appreciate the beauty and intricacy of the performance. If you're enjoying this journey through the cosmos with me, don't forget to subscribe and join our crew of space explorers. There's so much more to discover. Let's explore the universe together.